Thanks so much for having us today. Excited to be here and learn about all the other technologies as well. I'm Andy Gotshalk, CEO of Neurologic Solutions, and I want to talk to you a little bit about epilepsy. And I'm not sure if you guys know this story of FloJo, Florence Griffith Joyner, the world's fastest woman back in the 90s. In 1996, she was rushed to a hospital with seizure-like symptoms, and at that time there was no epilepsy diagnosis. So she went on and was living what would have been her normal life. And unfortunately, in 1998, she suffered another seizure, and due to complications from that seizure, she ended up passing away, which is incredibly unfortunate, obviously. There's a big problem in this country still with misdiagnosis and around the world of epilepsy. Both ways, both false positives and false negatives. Annually, there are over 5 million people globally with new onsets of these kinds of symptoms. And unfortunately, the number we talk about today is at least 30% are misdiagnosed at that first visit. That's a really big number, and in some cases it's even bigger than that, and it's over a long period of time in terms of trying to get to what that final diagnosis would be. This is a huge burden on society. It leads to a lot of unnecessary treatments, a lot of medication that's being prescribed. From that FloJo example, we've shifted into really generating a lot more false positives and leading towards diagnosing towards epilepsy, prescribing a lot of ASMs, anti-seizure medications, to these patients that really are going to be unnecessary and cause a lot of additional side effects. In addition, it causes lifestyle changes. If you have anyone in your family that suffers from epilepsy, you may know they're not allowed to drive. They suffer consequences from work and not being able to be as productive, and a huge real burden to society. So where does this misdiagnosis come from? Well, there is no biomarker for epilepsy today. I love this discussion on gene therapy and all these cancer treatments, and I wish we could do the same for epilepsy. But right now we can't. There is no biomarker. What do we do today? We look at EEGs. This is an EEG on the right. And the biggest problem today is when you look at an EEG, you're looking for a signature. You're looking for a pattern. What that means is you're looking for that seizure activity. Unfortunately, that patient, when they get that EEG, they're no longer having seizures. There's a big time delay between when they had these symptoms and when they go to the doctor and are able to get that EEG and try to see what's going on. So it most times comes back as normal, or potentially there are artifacts related to it. So in the longer scope of what is this course of treatment today and what are we doing with these patients, we're going to start with that EEG. We're going to look at it, see what might be going on. We're going to then intervene. We're going to make the assumption we can't have these patients die on us in the future. Let's try medication, try all these drugs that may or may not work. And it takes a long time to test all of these drugs. We may then move to more invasive monitoring, bring the patients into the hospital, bring them into the epilepsy monitoring unit, monitor them in-house for 24 hours, for days at a time, because what are we looking for again? We're looking for that signature in the EEG. And so if they're in the hospital, then maybe we can find that signature in the EEG and hopefully treat them. This process takes a long time, takes 3 to 5 years, if not longer sometimes. And what we really need is this accurate, reliable diagnosis, and the key thing is a shorter period of time. How quickly can we get that accurate diagnosis? That's where we come into play, and that's where we've developed EpiScalp. It was developed here at Johns Hopkins in the lab of Dr. Sri Sarma, who many of you may know. It is a pure software solution. It leverages technology that is being already used in clinicians' offices, in hospitals, in epilepsy monitoring units, all over the country and the world. People are getting EEGs every day. The data is already out there. All that we're doing is layering an algorithm on top of that data. So that EEG is being done on these patients on the left side. And now we are implementing this algorithm at that very first EEG, the first time you have these symptoms. Let's try to figure out what's going on. We are going to now layer this EpiScalp algorithm and try to give you a diagnosis of whether or not you have epilepsy. What's under the hood? We're using a lot of dynamic models, a lot of network modeling, and our underlying premise is a brain with epilepsy always has epilepsy. So it's not just when you're having the seizures that you have it. And again, remember, these EEGs, if you're not having the seizure, they can't pick out the signature. Well, we believe your brain always is having these signals of seizures. There's activity going back and forth. And that's what these algorithms have been able to figure out. Where is this activity going? Because the brain is trying to suppress this activity that's leading to potentially seizures, and the brain does a great job of it most of the time, until it doesn't. and then you have seizures and complications and bad things start to happen. So we're picking up that activity that's happening all of the time, and when we can bring this to market, we will start to be able to treat patients much faster and much better. So how have we proved this? We started with a retrospective study on 200 patients, all of which were diagnosed with epilepsy initially. So all of these dots, if you can see them, were all diagnosed with epilepsy. At the end of 3 to 5 years, what came out was there were 54% that were misdiagnosed. That's all of the ones on the right side. We ran our algorithm on all of these initial EEGs, and you can start to see what that separation is. In the top left saying, yes, we thought that was epilepsy. In the bottom right, we would have told those patients immediately, you do not have epilepsy, you do not need to be on that medication. That was done, and so now we've moved forward, and we've started a prospective study with over 1,000 patients happening at 3 centers across mostly the East Coast, here at Johns Hopkins, at Thomas Jefferson Hospital, and University of Maryland. Now we're trying to replicate that on a more heterogeneous population, really trying to get these first-time EEGs. We're just at the beginning of it, so we've recruited over 600 patients. We've started collecting these EEGs. We've started getting the scores. The big piece about this is we're not going to know definitively until, unfortunately, years pass, because we're not affecting the treatment of these patients. We're just monitoring them, getting the scores, and then when they have a definitive diagnosis a year, 2, 3 years later, we'll then be able to confirm and say, if you had trusted us at the very beginning, this is how we would have treated these patients, or this is what we could have done. In terms of competition, the piece I want to really stress is we are looking at this problem very differently. We're not looking for a signature in the EEG. We're not looking for that specific pattern. We're actually trying to treat patients at this first EEG, a normal EEG, and be able to predict whether or not they actually have epilepsy. We believe there's an easier pathway here for reimbursement as well with CPT codes that are available, and we can do it on any EEG. Any EEG that's collected, we're able to run this algorithm and provide better results to these patients. Huge benefits for lots of people. Hospitals. What this is going to do is allow more patients to get treated more accurately and faster. So one of the typical treatments for patients with epilepsy is surgery. Unfortunately, a lot of patients go in there and get pre-surgical treatment and go through this whole process hoping to get surgery, and then they find out they don't have epilepsy. And it ends up being a huge loss for the patient because they can't get the treatment, but the hospital as well. And very costly for the hospital, and then not as profitable because epilepsy surgeries can be very profitable for the hospitals. Payers having to prescribe tons of medication that aren't needed would be able to save tremendous amounts of money. I mentioned at the beginning the impact to society and people that are diagnosed with epilepsy having this problem of not being able to drive, jobs, all of those impacts, heavily, heavily reduced, and certainly patients and families. If you have a family member with epilepsy, it's unbelievable when they're having seizures and we just don't know why. We don't know why, we don't know how to treat them. This would give, hopefully, much better treatment much sooner to these families and to these patients. In terms of what our plan is moving forward, I mentioned we're in the middle of the study that's ongoing, that's going to still be another 1.5 years away, 2 years from completion. We're looking towards the next couple of years of really strengthening our regulatory and reimbursement process and strategies, looking towards next year actually as an initial indication of 510K regulatory clearance so that we can start sales actually in 2027. We're going to need to improve our integration and our GUI development. Again, it's software only, which makes it a lot easier than a device or disposables, but it will take some time and it will take some money. We're hopefully collecting a lot more data at this time too to support future submissions regulatory-wise. Our ultimate goal is a true diagnostic for epilepsy, and we're going to need more data to support that. We're looking for $8 million of funding to support all of this activity. $3 million of it has already been secured, and that's what's allowing this research study to go on right now through an SBIR Phase 2 grant. The rest of it is going to go towards the activities that I just mentioned, whether it's regulatory or quality or reimbursement, and hiring the team to continue the growth of this. In terms of the team, as I mentioned, this was developed out of Dr. Sarmer's lab at Johns Hopkins as our president and co-founder. Jorge Gonzalez-Martinez, who is a neurosurgeon up at UPMC, has been integral in talking about the impacts of epilepsy on these patients and the surgery and the process to get these patients to the right treatment at the right time. And 2 amazing engineers that are here right now and are both graduates of Johns Hopkins, Mark Hayes and Gulnush Kamali. Thank you, and I'll take any questions.